So yes, you heard me right. We can represent numbers as just functions. In fact, that's the goal of Lambda Calculus, to represent everything as functions. In this video, I will explain how this works and what it lets us do. First of all, we have to go over the basics. Every function is written like this. Now very simply, lambda tells us the input variable of the function, which is the term after it. In this case, it would be x. Next there is a dot. That just separates the first part from the second. What comes after the dot is the instructions. In this case, also x, but it could look like other things. This function we can call cool. Now cool of w would just replace every instance of x in the second part after lambda x dot with a w, so it would just return w. Now many functions will have two variables or more. For example, cool2 equals lambda x dot, lambda y dot, xy. What happens here is cool2 needs two inputs, one after the other, as it returns a function after application. This means we need to do cool2 of pq, which looks like this, lambda x dot, lambda y dot, xy of pq. Now, when we apply this, we apply it from left to right, which means xyz is read as x applied to y, then the result applied to z. Meaning first we do the x's, and we replace all the x's with p's, giving us lambda y dot py of q, which then becomes pq. Now, function inputs can be other functions, so we can actually do cool2 of cool and p, which is this. First we replace x's with cool, and get lambda y dot cool y of p. Next we do the y's, and now we have cool of p, which is just lambda x dot x of p, or just p. Now how about we do something actually useful? What if we make booleans, true and false, but what would they be? Let's say true equals lambda x dot lambda y dot x. What this function does is, let's say we have true of a and b. It will return a, the first option. This is because we do lambda x dot lambda y dot x of a and b. First we sub a into x, and we get lambda y dot a of b, and then we sub b into y, which just leaves us with a. For false, we can say false equals lambda x dot lambda y dot y, so false of ab is b, or the second option. True and false are opposites of each other. So now we could imagine having a function that gives true or false called condition, and condition of ab would give a or b depending on whether it evaluates to true or false. Now, what if we want to affect the booleans? Let's try to create a simple function, not. Not of true is false, and not of false is true. So not starts with lambda x as it has one input. But what follows is important. Remember, for true we choose the first option, and for false we choose the second. So we want our first option to be false, and our second to be true. This gives us not equals lambda x dot x false true. So let's say we do not true. We firstly sub true in for x and get true false true. Now true of false and true is just the first option, so it's false. So not true is false. So now what about another function, like and? Firstly, since and takes two inputs, and equals lambda a dot lambda b dot. Now let's think for a second. And asks the first boolean what to do. If the first boolean is true, we want it to choose the other boolean to check if it's true. But if it's false, we don't need it to even check the other one. This gives us and equals lambda a dot lambda b dot aba. If a is true, we output b, and if a is false, we output a. So if we do and true false, we get a equals true and b equals false. So true false true, which is false, as the starting true chooses the first option, which would be false, meaning and true false is false. If you want, you can try to figure out how to get or exclusive or with Lambda Calculus. I'll show the solution in 5 seconds. Try to give it a go. So how do we get numbers? Well, just like everything else, numbers are functions. How we represent numbers is like this. 0 equals lambda f dot, lambda x dot x, 1 equals lambda f dot lambda x dot fx, 2 equals lambda f dot lambda x dot ffx, and so on, with the number being the number of f's. Effectively, what a number is in lambda calculus is a function that repeats another function that number of times. For example, 3pq would be lambda f dot lambda x dot fffx of pq. This would become lambda x dot pppx of q, and then pppq, which applies the function p on q 3 times. Now that we have a number, let's try to do a bit of arithmetic. What if we want to add 1 to a number? First of all, we take in one input, so add 1 equals lambda n dot. But how do we add 1? Well, if we think back to when we did 3pq, it gave us the right hand side of 3, without the lambda f dot and the lambda x dot. To change the 3 to a 4, all we'd have to do is append another p to the start. How we can do that is by doing p 3pq, which is applying p to 3pq one more time. This results in ppppq, which is almost 4. All that is missing is the lambda p dot and lambda q dot, which we can just add at the start. The fact we are using p and q instead of f and x doesn't matter, as they are both just placeholders. This means 4 equals lambda p dot lambda q dot p 3pq. Now, if we want to change 3 to any n, add 1 equals lambda n dot lambda p dot lambda q dot p npq. If we try this on 4, we do add 1 4. We replace all n's with 4 and get lambda p dot lambda q dot p 4pq. Now 4pq is lambda f dot lambda x dot ffffx of pq. We replace all the f's with p's and the x with q, resulting in pppq. If we sub that back in, we get lambda p dot lambda q dot pppppq, which is the definition of 5. So, what if we want to do addition and create an add function? Well, first of all, we can think of addition between a and b as increasing b by 1 a number of times. Knowing this, we can also look back at what numbers do. If we do 2 of p and q, it applies p to q twice. So what if to add 2 to 3 we apply add 1 to 3 twice? That would look like this: 2 add 1 3, with 2 repeating add 1 on 3 twice, since 2 is a function. In general, our add function would have 2 inputs, lambda a dot and lambda b dot. We can replace 2 and 3 with a and b to make the function apply to any 2 numbers, giving us add equals lambda a dot lambda b dot a add 1b. Now let's try this for 3 plus 4. We do add 3 4. We replace a with 3 and b with 4, giving 3 add 1 4. Now 3 is defined as lambda f dot lambda x dot fffx. So we now replace all f's with add 1s and all x's with 4s, giving add 1 add 1 add 1 4. Now add 1 4 is 5 and add 1 5 is 6. Lastly, add 1 6 is 7, so add 3 4 is 7. So now you know another fundamental to programming. If you want to, you can try to figure out multiplication. If you enjoyed the video, please like, comment and subscribe. I hope you learned something new, and have a nice day.